Okay, welcome everybody to geometry. Today we're going to learn about trigonometry. We're actually going to start the first official day of trigonometry. So it's a big jump up in your math careers. But what we're going to do first is we're going to review what we've been doing, simplifying radical special right triangles. So you should have an assignment. If you don't have it, make sure you go get it. And hold on, let me find it real quick. Let's see, it is right here, okay? So you should have this assignment right here. And there's three problems that I want you to review. One is simplifying a radical, and finding the missing side lengths of these. So go ahead and pause me and try those problems out. If you're not sure how to do them, or if you think you got them and want to check with your classmate. You should have a partner. And then when you're done, let me know what you get and I'll confirm. Or I'll work these three problems out in the video so you can come back and see the solutions, okay? Okay, so here's the first one. Basically started factoring down to 150, got it down to that, broke it down in 25, took out 5 times 5, and then when I pulled out that was the 5. 2 times 3 is 6. Okay, so let's go ahead and try number 2. Okay, so the first thing is this. What you should notice at this point, hopefully, is that you've got a right triangle. You're finding the side of the right triangle, but you only have one side. However, you have an angle. So that tells you it's 45, so you should automatically think 45, 45, 90. That means you want to examine this side. Is it a leg or the hypotenuse? It's the leg, right, of the 45. So that means that the other leg is going to be the same, right? So that means that's going to also be 3, y is going to be 3 root 2. You'd probably be done, but again, I want you to be able to figure out how to get a hypotenuse, since on the exam it's not going to be multiple choice. You'll need to be able to figure out both. So you should also know that the short side times root 2 is equal to the hypotenuse. So that would be 3 root 2 times root 2 again. Remember, those two turn into just 2, and 3 times 2 is 6, okay? So that's why it's D, okay? So go ahead and try number 3. Okay, so basically we've got another trying to find the sides of a right triangle. We see it's a 30, 60, 90. We know that we've got one side which is 6, so we should know that that's the hypotenuse. Also, from our notes, we see that when you take the hypotenuse and you divide it by 2, you get the short side. So that would be 3. What's the short side? The side that corresponds to the 30, which would be 3 right there. And then basically all you got to do is take that short side, or 3 times root 3, to get the long side. So that means 3 root 3. So x is 3 root 3 and y is 3. Okay, so there you go. There you go. All right, guys, so that's the review for the day. Now, what are we going to do? What are we going to do when we learn about trig ratios? Why are we learning about something called trig ratios? So let's go to page 11 and see what's going on. Let me see if I can get there quicker. Come on, get back here. Okay, so what do we know about trig ratios? Well, it turns out that, and maybe I should back up a little bit. Let me give you an introduction. So there's two types of triangles, right? That if we've got, let's look back at the review. Both problem number 1 and problem number 2, we were trying to find the sides of a right triangle, right? We only had one side. So if we know that it's a 45, 45, 90 or a 30, 60, 90, we know ratios that apply to them. Well, the truth is there's a ratio for any kind. You don't have to take notes on this, but there's a ratio. Let's say if I know that that's 6, for example, but instead of this being like 30 or 45, let's say it's 20. Well, the truth is there's ratios for every single triangle. That's a right triangle. I'm going to reconfirm. That's a right triangle. There's ratios for every single one if you have one side and the degree of it. Because remember, if you know it's a right triangle and you have one of the non-90 degree angles, basically you have all three angles. And it's a similar triangle. So any other triangle that's 90, 20, which would be 70, right? Because it has to equal 180. Those are going to be similar to each other. So the point is we can figure it out. And the way to do it is through trigonometry. But the first thing we got to learn about is that there's certain ratios that apply when you're dealing with trigonometry. So let's go ahead and take some notes. What's a reference angle? It's the angle, it's the non-90 degree angle you are given. Okay, so in this case, this is represented by this. It's called theta. It's like a O with a line through it. That's considered the reference angle, not the 90-degree angle, but that one. And so based upon that, we're going to get a ratio of sides. So this is something that's very important. You're going to write maybe the first time now, but you put it here. It's called SOHCAHTOA. Okay? Really, what is SO? SO is really going to be opposite side. So I'm going to put op for short, but it means opposite side over H, which is hypotenuse. So I'm going to abbreviate hypotenuse. Okay, so that's the ratio. Cosine, which is COS. This is called sine. It looks like sin, but it's sine of that reference angle. Cosine is the opposite. Oh, my bad. Cosine is A and H. What does that mean? It means the first letter is going to be on top. Actually, I should say it like this. The first letter, this, refers to either sine, cosine, it's an abbreviation, or tangent, okay? So cosine, we're doing that one now, right? So that's equal to the first letter here, which is adjacent, and I'll talk about that in a moment, over hypotenuse. And finally, tangent is O over A, which is opposite side over adjacent. Okay, now what does that mean in terms of this triangle? Well, the opposite of the reference angle, which is going to always be the one with the theta, or at least whatever's given, is going to be opposite, just like we matched up sides and angles before. So that's your opposite. So go ahead and abbreviate that. If you want to write the whole thing for as you're learning it, that's good. The hypotenuse is always opposite of the 90-degree. So hypotenuse. And then whatever is left over after you've identified the opposite and the hypotenuse is the adjacent. So that would be this side is the adjacent side. What does it mean? Why are we calling it adjacent? Because it's a side that is part of what forms the reference angle. And again, it's the last one left over. All right, so let's go ahead and look at the next few problems here. So we're going to write trig ratios. Again, these are trig ratios right there for angles A. Remember, when you see it like this, it means angle A is going to be the angle right here. Angle C is going to be this angle, okay? And we're going to write these ratios for these angles in terms of their side lengths, okay? So I'll do the first one for you, and then you can think of the second one. Okay, what is sine A? Well, we know that sine is going to be opposite. Again, write it out. I'm going to write it right here. SOHCAHTOA, okay? So sine is this one. So it means O over H. Cosine means A over H. Tangent means O over A. So I'm going to get opposite over H, but we're doing sine angle A. That's this one. So let's start with that. So what is the opposite? So this is what I always tell students. Start by writing your generic abbreviation, and then put in the actual numbers that go with it, or whatever it refers to. So what is the opposite of A? A is down here, so the opposite of that is over here, which is going to be X over hypotenuse. Hypotenuse is the opposite of B, so that's Z, okay? Oops, I don't like my Z. Okay, all right, so what I want you to do is you guys do the next one and then come back and see how I do it. And then, so maybe go ahead and pause me and then I'll show you how to do it. Okay, now we're going to do cosine. We're still on angle A for all three of these, but now we're going to do cosine. That's A over H. So I'm going to just abbreviate A over H now for adjacent. What is the adjacent of A? Well, again, this is the, oh, by the way, since we had A, angle A, let's go ahead and label these opposite so we can keep it straight. Half the battle is keeping things straight. Okay, adjacent. Okay. Now, so the adjacent from A is going to be Y. Okay. Hypotenuse is still Z. Okay. Excellent. Now try tangent and come back and check it out. Okay. So tangent is O over A. So O, or opposite, not 0, but O over adjacent. So what's the opposite in this case? Again, it is 0, and the adjacent is Y. Okay. So that's how it works. Now, You may want to try this one to see if you can get it and pause me. But if not, I'll go ahead and do it right now. So now we're going to jump to angle C. Okay, all these are angle C. So I'm going to go ahead and get rid of this for a second and just make sure that, there we go. So angle C, I can clear out this stuff. I could almost clear out the whole thing. Okay. Okay. So angle C is now this one. I'm going to do this in a different color. There we go. So angle C is this one. I'll do this one in red. Okay, so we're doing angle C. So what is the opposite of C? From this perspective, now Y becomes the opposite, right? From C. This still stays a hypotenuse. It's always the opposite of the 90, which means the only one left over is the adjacent, which is X. So sine is opposite over hypotenuse. In this case, opposite is the Y. Hypotenuse is still the Z. Okay, good. There we go. Cosine, adjacent over hypotenuse, A over H. Adjacent is X over hypotenuse is still Z. Finally, tangent C is going to be OA, O over H, no, over A, my bad. O is again Y over A, which is the X, okay? So there you go, that's how you do it. Okay, we'll come back to this in a little bit. Okay, so now what we're going to do is we're going to go to the assignment today. So everybody go to your assignment and we'll do the first few questions together. How about that? We'll do 4 and 5 together and then I'll let you guys do the rest. So okay, so let's do the first one. Now, again, as you're learning this, I highly recommend every time you're working on it, write this out. If you ask me for help, I'm going to say, have you written down your SOHCAHTOA yet? That's the first thing, okay? And again, it always remains sine is equal to opposite over hypotenuse, right? That's what this means. Etc. Okay, so we're looking for sine x, okay? That's our angle. So step number 1, angle x, where is it? Well, here's x, so that would be angle x. Let's label. Step number 1, label. Take some label. So x is right here. So what is the opposite of x? It's going to be 24. So, or right, it's going to be there, okay? Okay, the hypotenuse is always opposite of y, so I'm going to write h for that, which there's only one left over, so that's the 18, so that's got to be the A. So that's got to be the adjacent, okay? So adjacent, opposite hypotenuse. So we're looking for sine x. So again, I always highly recommend writing the generic abbreviations and then filling it in. What's the opposite? Well, we figured out that it's this side, so it's 24 over hypotenuse 30, okay? So I think that's correct, but wait a minute, where's the answer? Okay, so you're going to have to remember you've got to reduce fractions if you've got numbers. So if you're not sure what it is, start saying, well, what can I divide 24 by? I can divide that by 2, and I also have to divide 30 by 2. So that would be 12 over 15. Still don't see it. They're both divisible by 3. So that's 4 over 5. Okay, so now we got our correct answer. That's how you do it. So you guys go ahead and do, and I'll tell you, I'm going to show you an example on your calculator if you need to figure it out, and how to convert fractions into reduced forms. I'll show you that in just a second. Okay, I'm going to show you how to convert a fraction like 24 over 30 into its most reduced form to get that. Okay, so you grab a calculator. And if you're stuck there and you don't know how to get out of it, always remember you can go second, quit, okay? First thing is to go 24, convert it to a decimal, like that. Just divide it out, right? 0.8. And then go to math. Click 1, which is already on fraction, so 1. And then you got to hit enter. And then see how it's 4 over 5? So that's how you convert it, okay? Now, I'm going to let you do one more, and then I'll come back to the answer. And I got to go quick because I'm about to run out of video. Okay, I labeled the sides based upon angle A, cosines A over H, which was 24 over 30. Remember, we reduced that just like this to 4 over 5, and it's just a coincidence that the answer is the same. It's not always going to be the same. So you guys finish the assignment. That's it.